Hello and welcome to this video about searching. In this video, we are going to learn about the first topic, that is binary search. Now let's take an example. Now let us learn through an example. Let's take a small array. So you know how the key of the array works, right? This is position 0, this is 1, this is 2, 3, 4, 5, 6. So this is an array of size 7 it has. So let's put random values to it. Let's put 2, 4, 6, 8, 10, 12, 14, right? Random. Now let's say our key value. Now key value is the value that we say that we have to find. So let's say our key value is 10. Now what we are going to do here is, if we didn't know how we use search or other sort. So what we would do, we would first one by one start looking into the elements here. So now we would first look into the first element, then go for the second element, then third, fourth, fifth, and then we would find our key on the fourth position. Now this is very inefficient, right? This will take up a lot of our time and it's also going to cost us a lot. It's not feasible, right? Given the current situations where everyone wants everything within seconds. So now we have found different terms and different ways that we can use to search an element. One of such we will be learning today, that is called the binary searching. Now what we do in binary searching is that first we will take the 0th position, right? Sorry, yeah, 0th position, and then we have the 7th position. Sorry, the 6th position. So this is called the low, and this here is called the high. And now, what is the mid of this? 0 plus 6 is equal to 6, and 6 divided by 2 is equal to 3, right? So now the mid of this is 3. So now this is how we first start off. We label three, uh, 3 points which are low, mid and high. Now what we are going to do is we'll see the mid. Now is the mid the key value of mid, that is 8 over here, is it more than the key value or is it less than the key value? Over here we can see that it is less than the key value. So then we move to the next one. So what we're going to do is, this mid right here will be shifting. So first we'll have the low. Low will come shift to where the mid was, right? The low will shift to 4 over here, right? Now this will be a new low. Let me change the color so it's easier to understand. And this is a new low, right? And this will maintain our high. We are not going to change the high. Now what is the mid of this? 4 plus 6 by 2. What is that? 10 by 2, which is equal to 5. So here this will become a new mid. Now what's going to happen is we are going to check again if the mid is more or less than the key. So here you can see it's more than the key. So now what we'll do is we'll shift the high value towards the mid value, right? So now the low value will remain 4. The high value will also remain 4. So now here the low and high will remain 4, and hence the mid value will also be 4, because 4 plus 4 by 2 is nothing but 4. So now what we do is we henceforth find our key value over here on 4. Now this is way more efficient than what we would do if we had to find one by one for each element, right? So this is what this entire process is called binary searching. Now let us look for it into the coding version. Let us look at it into a C++ example. So now we are going to start with the usual, the header, the namespace. Now from here we are going to start. So what we are doing is we are first defining an integer called binary search, which will have int a, int key and int length as their variables, right? Then moving on, inside this we write the code block. So again we are defining it as the int low, high and middle. These are three variables that we'll be using for the binary search like we had told before. So first as usual we'll start with the 0th position as the low, and the height position is the length minus 1. Because why length minus 1? Because whenever there's an array it starts with 0, right? So if there's 0 and there's 4 over here, then the length of this will be 4 minus 1. Sorry, the height of this will be 4 minus 1, right? So sorry, the length is 5, not 4. 5 minus 1, which is the fourth version. So with 0 it's always plus 1, so hence we use minus 1 over here. So now we'll put a while loop, so that we can alter our low and high positions accordingly. So first in the while loop we'll give the condition that if low is less than or equal to the high, right, then the middle is equal to low plus high by 2. So we'll find the middle. It's simple, we find low plus high by 2. Now if key is equal to a middle, so basically if the key is found in the middle, then we return the middle value, right? And if the key is not found, that is very simple one step answer. But then if the key is not found, we have to alter the middle, the high or the lower value. So let's say when it's not found and the high is equal to middle minus 1, or else the high low will be equal to middle plus 1. Either one of those conditions will be true, right? So the key will be either more than the mid value or less than the mid value. So we'll shift it accordingly like we had done in the previous example. And then as usual we'll put the return one because we need a value returning. So now we'll write a int main code block over here. So over here we defined an array. Okay, so int numbers, the size of an array is 15, and then these are the values assigned. Now int index, what we had, we'll call the int by binary search, right? Binary search over here we had defined. So we have to write it in the same order. We'll have int a, then we have int key, and then int length. So it goes int a is nothing but numbers, int key is nothing but 21. You can give any. I have given 21 because it's over here, so it will give found or else it won't be found. And then 15 is the size. Int number, it's here, it's the size. Now if index is not equal to minus 1, cout is for printing, cout found at index, whatever the index it is found, and else cout not found. So here if instead of 21 we had a random value, let's say 40, right, there is no 40 over here. So after performing all the mid and high calculations, it will give us a not found value, whereas since it's 21 it will give us found at the value 5, index 5, I'm sorry, right? So it will give us the value found at 5, found at index 5. Thank you.